logistic regression as a benchmarking, and we also use classification tree to see if this model can perform better than the logistic regression. So I'm gonna pass it to Fan to talk about the actual model we have built.
Thank you. So we have built some models that predict the MSRP and the market categories. So before we build the models, this is what we have for the data exploratory. So this we use hierarchical clustering. The left chart, it shows the MSRP versus horsepower. So the algorithm already split the data into 4 clusters by price. So you see that the top is, so one cluster is above $70,000. The second cluster is between 50,000 and 70,000. The third cluster is lower than 50,000, and yet the last one is lower than 10,000. Also, the same with the age versus MSRP clusters. We see that the age right here, like if a car is older than around like 16 years old, then its price will drop down to around $10,000. Yep. So, we build we use regression models to tree regression to fit 3 data sets that we split to 3 buckets: low price, mid price, and high price. The low price would be the cars that have a price lower than 20,000. So this is like the simplest model that we have. So people who look for the cheap car first look at the age of the car. If it's less than 16 years old, then they will look at the horsepower. Yeah, and the one interesting thing about this is like it's actually correspondent to the age. The cutoff point of the model is, yeah, you showed in the cluster graph. So we already split the data into training and test set. So the training set has 75% of the data, and the test set has 25%. So the test mean square error is around 1,700.
So that's a mean square error.
The test mean square error.
Right. So you guys should make it more interpretable. You should take a square root, right?
Yeah.
So basically, the error is in the ballpark of 400 or something. Is that right?
No, we didn't. We didn't.
You did. So this is already rooted mean square.
It is.
Okay. Okay.
Yeah. Because if it's like only 400 or something, it would be too unreal.
Yeah, it would be.
So yeah, this is the mean. Yeah,
that would be a very good model.
Okay. Yeah.
All right. So already square rooted. So we're looking at about $1,700 error.
Yep.
Okay. Okay.
So the next model which will be the next bucket. So the car is around $20,000 and $35,000. This is pretty hard to see, but so people who look at these cars in the price range will look at first the horsepower. If it's over 200, then they will look at again horsepower and then the type of car. If it's the horsepower is lower than 200, then they will look at the fuel type and then vehicle type. And here the test root mean square error is 3,000. So
this is already pruned trees. Okay, after cross validation. Okay.
Yeah, after cross validation. Yeah. So it's like 9 terminal nodes. So and this is the high budget bucket, which is over $35,000. We can see that the horsepower also another first criteria for picking the car for the car price for the MSRP. And then if it's over 400, then they look at the origin of the car, whether they're from Japan, South Korea, or United States. And then if it's lower than 400, then and then we look at the fuel type. And here the test root mean square error is around 10,000. This happened because it's higher than the other because we have over 35,000. We have outliers in the $100,000. Yeah, that's why. And then we have Mason here. Will explain the models that we have for price category. I mean market category.
So just one comment before you guys move on. So we see a clear deterioration in model performance as you move from low budget to mid budget to high budget, right?
Yes.
So does that mean if people want to buy a cheap car,